Hello pre-calc students. We are starting Unit 7 on polynomial and later rational functions, and in day 1 we're going to do some polynomial division and find some zeros and some factors. So let's start with some definitions. Here we have a polynomial function in standard form, and if it's a polynomial function, all of the exponents have to be positive integers. Let's get a pen. So that means if you have a function like y equals x to the negative 2 plus x to the 1/2, this is not a polynomial function because this exponent is negative and this exponent is not an integer. So this is not polynomial. Alright, n, you'll notice n is one of the exponents, and it's the biggest exponent because all the other exponents come by subtracting something from n. So since n is the largest exponent, we learned in Algebra 2, that would be the degree of the polynomial function. A sub k, so all of the a's are in front of the x's. Remember that those are called the coefficients. Alright, but a sub n, that is the one that's right here, that's in front of the x with the largest exponent. So that one has a special name. It's called the lead coefficient. Because when you write it, the function in standard form, it would be first. Lead coefficient. Actually, I think more often we'd call it leading coefficient, so let me get that in there. Leading coefficient. And a sub 0, notice a sub 0 is back here by itself. It doesn't have an x with it, so it's just a number, and it's called the constant term. Okay, so looking at some example polynomials right here, the degree is the largest exponent. So largest exponent is 7. The largest exponent is 3. There is no exponent here because there's also no x. I could put in an x to the 0 power because that's 1. So I could say my degree is 0 here. And in this one, don't be fooled because the largest exponent's in the middle. So the degree is 8. Now the leading coefficient is the coefficient of the term with the biggest exponent. So in the first one it's 6. In the next one I don't see a number, so that would be a 1. The lead coefficient here is 12, and here it's going to be 1. And the constant is the term that doesn't have an x, 10. We don't have a constant term here, so you could either say none or 0. Here, you do have a constant term, and it's 12, which, remember, this 12x to the 0 just started out as a 12. And in this case, it's negative 4. Okay, so take a minute to decide whether each function is a polynomial function. Write it in standard form if it is, and say its degree and its leading coefficient. And you will probably want to pause the video to do that. And when I do it, I'm going to answer these questions in this order. 1, yes or no. And then if it's a yes, I'll answer 2, the standard form. And 3, its degree. And then 4, what's its leading coefficient. So pause the video and then come back. Alright, so number 1, I'm looking at the exponents. They are all positive integers, so yes, it's a polynomial function. Yes. Number 2, standard form. So I need to change the order so that the exponents go from the largest to the smallest. So f of x equals negative 3x to the 4th plus 1/2 x squared minus 7. Number 3, the degree is the largest exponent, which is 4. And number 4, the leading coefficient is in front of that x, so that would be negative 3. Okay, so next one, the exponents are 1 and 2, and then there's nothing here. So those are positive integers, so this is also a yes. In standard form, I need to rearrange my polynomials so the term with the largest exponent comes first, and they go in order. So that would be f of x equals pi x squared minus 0.05 x minus root 2, and 3, let's see, degree is the biggest exponent, so that's 2, and 4, the leading coefficient comes in front of that term, so the leading coefficient is pi. And in C, do you see the problem with this polynomial? It has a negative exponent, so this one is a no, and we don't need to analyze it. Alright, so polynomial functions, you have seen some of these before. Quadratic is an example of a polynomial function. A line is an example of a polynomial function. A cubic function is polynomial. Okay, and we're going to see other polynomials that have a few more terms in this unit, like so. And they have some characteristics that are common to all of them. So they are continuous. So they don't have any asymptotes or holes. Continuous. They have at most blank turning points. Well, it depends on the degree. If the degree is 2, they would have at most 1 turning point. So the turning points is 1 less than the degree. So 1 less than the degree. So find the degree in each example. The degree here is 3, which means that it has at most 2 turns. It could have fewer. And the degree here is 5, so it has at most 4 turns, but it could have fewer. The function of degree n has at most blank x-intercepts. So in Algebra 2 you learned this. It was the fundamental theorem of algebra. If your function has degree 2, then it could have at most 2 x-intercepts. And if the degree was 1, then it would have at most 1 x-intercept. So the degree is equal to the number of x-intercepts they could have at most. The x-intercepts are the zeros, solutions of the function. At an x-intercept, the value of the function. So let's think about that. That would be the y value. So the y value at the x-intercept is always 0. And the y-intercept happens when, let's look at this, the x is equal to 0. And that will be the same as the constant term, because when you put 0 for all your x's, the only thing that's left is your constant term. End behavior. The end behavior depends on the graph of the term with the highest degree. Highest degree. So if we're looking at one of our other polynomials, let's look at one example. Okay, let's say we were looking at number, this one right here, 6x to the 7th. All the rest of this becomes just not important when you're at the very ends of your function, and when you're going to positive infinity or negative infinity. The only thing that's going to matter at those points is the one that's being raised to the highest exponent. So at the ends of your function, all we care about is the 6 here, which is making the right side go up, and the 7, which tells you that your ends are going to go in opposite directions because it's an odd number. And we did study that in the last unit when we talked about end behavior. Okay, so we're going to go on to the next page and try some problems. When you divide a function by its divisor, you get the quotient plus the remainder over the divisor. So let's see how that works over here. We're going to do some long division, and long division works just like the long division that you did in elementary school, except the calculator won't help you here. So I have x squared minus 4, but I'm missing the middle term here, the x. I need a minus there. Minus 4. And then over here, I need to put a placeholder in for the x because I don't have an x term. So when I write it, I'll put a 0 there. 3x to the 3 minus 2x squared plus 0x minus 150. And then over here on the side, this is where I do some thinking as I'm working along. So I'm going to start by taking the first term, 3x to the third, and dividing it by the first term, x squared. And I'm going to get 3, and remember that when you divide, you subtract exponents, so you get 3x. And then put that above its like term here, 3x. Next, you multiply the 3x times the x squared minus 4. 3x times x squared plus 0x minus 4, and distribute that. So you'll get 3x to the 3. I still have 0, x squared, and then minus 12x. And then that is going to go back over here. 3x to the 3 plus 0x squared minus 12x. And then you subtract. Just like division from elementary school. Alright, so these two cancel. Negative 2 minus 0 is still negative 2, x squared. And this is a tricky one. I have 0 minus negative 12. So the two minuses cancel and give you a plus 12x, and then bring down the minus 150. So over on the side now, what you're thinking is the first term divided by the first term. Negative 2x squared divided by x squared. And those cancel, giving you just negative 2. And now I need to multiply the negative 2 times the x squared minus 4. Negative 2 x squared plus 0x minus 4. I get negative 2x squared plus 0x plus 8, because negative times negative. So negative 2x squared plus 0x plus 8, and subtract. So those cancel. 12 minus 0 is still 12. And I have negative 150 minus 8, which is negative 158. So now I can't divide 12x by x squared because the squared has a larger degree. So this is going to show up as part of my remainder. So my answer, start up here, the 3x minus 2, plus the remainder over the divisor. So this is my remainder, 12x minus 158, over my divisor. And when I write my divisor out, I'm going to write it in its simplest form, so I don't need to leave that 0x in the middle. X squared minus 4. Alright, synthetic division is a short method of performing division, but it only works when we're dividing by a first degree binomial, so that means that the exponent here has to be 1, and it could be x minus k or x plus k, and the coefficient of the x also has to be 1. So 1x plus a number, 1x minus a number, those are the only situations when it works, but because it's so easy, people like to use it when they can. Alright, so the first thing you want to do is you want to take your divisor, x plus 2, and set that equal to 0 to find out what number we're going to put in our first box. So we get negative 2 in our box. Negative 2 is the 0 that the divisor creates. Then we're going to take the coefficients of these numbers, and we're missing the x to the third, so we need a 0 for that. So 3x to the 4, 0x to the 3, negative 8x squared, negative 11, and positive 1. Okay, the procedure is a multiply-add procedure, which is different from the long division. Multiply, add, and repeat. The very first thing you do is you bring down the first number, 3, and then you multiply negative 2 times 3 to get negative 6, and you put that right here. So negative 2 times 3 gives you negative 6, and that goes right there. And then you add, and you get negative 6. Then you multiply again. Negative 2 times negative 6, and you get 12. And then you add, and you get 4. Okay, then negative 2 times 4 is negative 8. You add, and you get negative 19. And negative 2 times negative 19 is 38. And then you add, and you get 39. And now we need to interpret what we got here. So when you divide a fourth degree polynomial by a first degree polynomial, dividing, you subtract the exponents and you're going to end up with a third degree polynomial. And when you use synthetic division, because you always divide by a first degree polynomial, you're always going to go down 1 degree. So if we start with x to the 4, this is going to be 3x to the 3. And then we go down 1 degree for each term, so minus 6x to the 2 plus 4x minus 19, and the 39 is the remainder, so we're going to do the remainder over the divisor. Now remember, our divisor was x plus 2. The last term in synthetic division is always the remainder. Alright, so then you should pause the video and try this one before watching the solution. Alright, so set your divisor equal to 0 and you get x equals 1. That number goes in the box. And then you want to line up your coefficients. It doesn't look like we're missing any. 3, 2, 1, so we're good. So we have 2, negative 1, 2, negative 3. Bring down the first one and you have a 2. 1 times 2 is 2. Then add 1. 1 times 1 is 1. Then add 1 times 3 is 3. And then add. So our remainder is 0 this time. We started with x to the third, so that means that the degree of our answer is x to the 2. So we have 2x to the 2 plus 1x plus 3, and we don't have a remainder this time, so you don't have to write that part. Okay, let's turn the page. Alright, the remainder theorem is useful if you need to do f of a value, and then that value is just a little bit large for you to calculate in your head. So it could be really hard for you in your head to hold on to the numbers negative 3 to the 4th, and negative 3 to the 2, and negative 3. So if you do synthetic division, that's another way to find f of negative 3. So negative 3 is the 0, or it's not the 0, but it is the value. So you put that in the box. It's not the opposite in this case. And then you line up your coefficients. Negative 1, we're missing the x to the third, so we put a placeholder in. 3, negative 4, and negative 5. And we bring down the first one, multiply, add, let's see, bring it down, multiply, add, multiply, add, multiply, add, negative 30 and negative 42. So negative 47. So remember that when we're trying to find f of negative 3, the answer is the remainder. So in this case, we're not writing out a polynomial, we're just answering that question, and the answer is f of negative 3 is equal to negative 47. Alright, so you can test to see if a value is a 0 of the function by checking to see if the remainder is 0. If the remainder is 0, then that means it divided evenly. Let's see, and in this sentence here, it says zeros are also called roots, and they're also x-intercepts if they are real. If they are imaginary, then they would not be x-intercepts. Alright, so to test if 1 is a 0, you put the 1 in the box, and you have your coefficients, 1x to the 3, negative 4x squared, 9x, and minus 6. And we do the synthetic division, bring this 1 down, multiply, add, multiply, add, multiply, and add. And because the remainder is 0, we can say, yes, 1 is a 0. Alright, so you should pause it here and test to see if -4 is a 0 of this polynomial. So I'm going to put -4 in the box and line up my coefficients. 1, I'm missing x to the third, 1, -3, and 1. Bring it down and then multiply and add. Multiply and add. Oh, it's getting harder. -40, -68. And then add. Okay, and then 284 and add. Alright, so that got super big. F of -4 is 285, so it is not a 0. Okay, and then related to the zeros are the factors. If you divide by a factor and your remainder is 0, then you know that this binomial is a factor. So I want to find out if x minus 1 is a factor. So I'm trying to check again to see if the remainder is 0. So you take the factor x minus 1 and you set that equal to 0 to find the number that goes in the box. And then you line up your coefficients. 2 missing the next term, so 0, 3, -5, and 7. Bring down the first one, and then multiply, and add, multiply, and add, multiply, and add, and multiply, and add. So the remainder is not 0. It didn't divide evenly, so x minus 1 is not a factor. Because this is not 0. So you should pause it and try the next one. Now notice the next one, after we divide, it tells us -3 is a 0. You're going to end up with a quadratic function, and you want to continue factoring that quadratic function because it wants us to break this into 3 factors. So pause the video and give it a try, and then you can check your work. Alright, it tells us -3 is a 0, so -3 goes in the box, and we're going to line up 6, 19, 2, and -3, and we're going to divide it here. So bring down the 6, multiply, add, multiply, add, multiply, add. Now our remainder is 0, but that shouldn't surprise us because it told us -3 is a 0. So what we're going to take now is we're going to take our depressed polynomial, that's what we got after we divided, 6x squared plus 1x minus 1, and we need to factor that. Now if you're thinking back to Algebra 2 and you can't remember how to factor that, you're trying to find numbers that multiply to 6 times -1, so they have to multiply to -6 and they have to add to 1. So those numbers would be 3 and -2. Now because we have a number in front of the x squared, you can't just put those into the factors, so you need to split the middle term into 2 pieces, 3x and minus 2x. Bring down the -1, bring down the 6x squared. And then next you take a common factor out of the first 2, so I can factor out 3x, and I'm left with 2x plus 1. And I want this to make a 2x plus 1 also, so I'm going to factor out a -1, and I have a 2x plus 1. So then your inside factor is 2x plus 1, and that is being multiplied by both the 3x and the -1, so that makes up another factor. Alright, so those are the factors of 6x squared plus 1x minus 1. But remember that we also took the 0, -3 out. If negative 3 is a 0, then x plus 3 is a factor. And those are your three factors of f of x. So, at this point, if you finished all of the notes, you should go to the homework assignment and try those problems.